Warm welcome to all the viewers. Friends, in this video, I am going to particularly talk about mixture modeling. So, as you know, that mixture modeling is a statistical technique which deals with finding out the unobserved heterogeneity prevalent in the data. So, we are trying to identify the unobserved subgroups or known as classes within a population. It is of several types: latent class analysis, latent profile analysis, latent transition analysis, factor mixture modeling, and growth mixture modeling. So these are the subtypes of mixture modeling. Quickly, let us revise what is latent class analysis. In latent class analysis, the subgroups are identified based upon the observed indicators which are categorical in nature. So, observed indicators which are categorical in nature, maybe they have a binary response like yes or no, or ordinal response like Likert scale response. In latent profile analysis, the data which we analyze over here is the observed indicators or the observed variables must be continuous in nature. Must be continuous in nature. In latent transition analysis, which is an extension of latent class analysis and considers categorical data, we are trying to examine the shift of respondents from one class to another class over a period of time. Say we measured their response at time 1 and we measured their response at time 2. So at time 1, maybe we found out 3 classes: class 1, class 2 and class 3. One of the respondents who was lying in class 1 at time 1, in time 2, that respondent might shift to class 2. So this is the idea behind it. So we are trying to estimate that respondent which was existing in class 1 at time 1 point, now at time 2 point, when we took in the repeated measurement, that respondent has shifted the class and now belongs to class 2, the same respondent. So this is a simple idea to help us understand what is latent transition analysis. In factor mixture modeling, continuous latent factors within each hidden categorical latent class. So within each latent class, what are the continuous latent factors? So it combines continuous as well as categorical variables and known as factor mixture modeling. Individuals stay in the same latent class for entire duration of the study. Now this is important about factor mixture modeling and growth mixture modeling. They do not change their classes. The respondents remain in the same class. Growth mixture modeling is used for longitudinal data to identify subgroups that follow different trajectories over time. So this is a repeated measurement design. But when we talk about factor mixture modeling, this is cross-sectional in design. Cross-sectional means the observations are measured at one point of time, and in growth mixture modeling it is longitudinal. That means we take measurements at different point of time, just like I explained you in latent transition analysis at time 1, time 2, time 3. So that is the difference between these 5 types of mixture modeling. Now let us understand that how to determine the number of classes based upon the results which we get from M plus, latent gold, or we are doing mixture modeling in our software. What are the indices or the parameters we should look in for while assessing or estimating the number of classes, because that is the motive behind doing mixture modeling, right? So let us see. The first criteria is absolute model fit. So what do you mean by absolute model fit? In absolute model fit, we are concerned with that whether the data points the predicted data fits with the observed data or not. So that is the idea behind regression also, right? The predicted data fits with the observed data or not, or we can say observed data fits with the predicted data or not. So we use Pearson chi-square statistic, right? Or we use log likelihood ratio. So the p value in this case has to be insignificant, that is greater than 0.05. In case it is greater than 0.05, then we fail to reject the null hypothesis, which says that there is no difference between the observed data and the predicted data, right? So there is no difference, and that is what we want. So we are judging the qualitative differences between the classes when we are determining the number of classes. So first is absolute model fit, where we assess whether our data fits to the predicted values or not, and we assess it through log likelihood ratio. The p value should be greater than 0.05. Now the problem is that log likelihood is quite sensitive to higher sample sizes, and in case you have high sample size, then you might not get the p value which is insignificant. And similarly, Pearson chi-square is sensitive to small sample sizes. In case you have small sample size, then you fail to get a p value which is insignificant. So that is why we go on to checking on the second criteria, which is descriptive model comparison. So what do we do in descriptive model comparison? In this, we check on the values of AIC, Akaik's information criteria, Bayesian information criterion. Now, Bayesian information criterion is basically used for simpler models, but AIC can be used for complex models. In case your model is complex, having lot of predictors, and there's a complex structure, then you can go in for ISC, AIC, otherwise you can go with BIC. The lower value of AIC or BIC in a model shows that the model is better than the previous one. It should be lowest for the good model, right? Now, what is the third criteria? Third is inferential comparison. In this, we are testing the significance of different models. In this, we use parametric bootstrapping for assessing the hypothesis, that is whether 3-class model is better than a 2-class model. So we use parametric bootstrapping, and if the p value is significant, that is less than 0.05 at 95% confidence interval, that is the testing level we have adopted for our tests, then we reject the 2-class model. So if p value is significant, then we reject the 2-class model and we say that 3-class model is better than 2-class model. Okay, so this is how we do testing through parametric bootstrapping, for which you will automatically get the results in the software, and this test is known as likelihood ratio difference, so denoted by delta G square, likelihood ratio difference test. Why bootstrapping is used in this case? Bootstrapping is used to generate empirical distribution of likelihood ratio chi-square and compare the empirical or the observed value with this bootstrapped significance value, right? Now we come to the fourth criteria of assessing the number of classes, that is substantive considerations. So these considerations help us to determine the number of classes based upon the worthiness of the solution. That is, whether the solution is desirable and it makes sense. It should be desirable and it should make sense. Sensible as per the theory, as per the background, as per the extensive review which you have conducted on the topic. And the hypothesis and expected classes So one should hypothesize beforehand that what is the number of expected classes in a particular type of study domain which he or she is pursuing based upon the previous researches done by the other academicians. So in this case we come to know that whether a 3-class solution which we got, and we saw that it is better as seen through descriptive model comparison and inferential comparison. If we deem that 3-class model is better than the 2-class model, then we should be able to justify what names we will give to these 3 classes which have been formed out of that data. So how they will signify the particular group of respondents in class 1. So class 1 will denote which kind of respondents, class 2 will denote which kind of respondents, what attribute can we relate with these classes. So this is what we mean by finding out desirable sensible solution, that is sensible class solution for our mixture modeling analysis. Very soon I will be making a video on mixture modeling where I will show you how to conduct latent class analysis, latent profile analysis in latent gold software. And we will compare that why latent gold is better in giving us more detailed results as compared to Jamovi in case of mixture modeling. We can do this in Jamovi software as well. So just wait for a while for the upcoming video on mixture modeling, wherein I will show you a practical example of how to do this. So I hope the content was informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, thanks a lot.